Hello everyone, welcome to Minery. Programming at its base is incomplete without talking about electronics. So, today we are going to talk about a fundamental component called IC7805. So let's start. Often, while dealing with electronic circuits, we find it as a necessity to regulate an input voltage source to fix stable output voltage. Also, voltage fluctuations in the circuit needs to be stabilized to make the circuit function in an authentic order. To meet this purpose, in a handy fashion, we have 78XX IC series. The XX here defines output voltage catered by it as output to the circuit. In our concerned video of IC7805, the XX is obviously on 05. So the output stable voltage is plus 5 volt to the circuit. It is often confused between a Zener diode and 7805 IC. The both of them apparently regulates voltages, but their architecture and scopes are largely different. IC7805 is a series regulator formed by using several transistors, while Zener diode is a shunt regulator which clips off the excessive voltage appearing across it. Also, 7805 has an advantage, the current limiting. Overload the current and it will be limited to a safe value, for the regulator of course. Hence, even if they are apparently doing the same job, not actually, that's why I used apparently, they're extremely different from each other. So let us explore 7805 a little more. First of all, the properties of the 7805. The 7805 IC rating. Input voltage ranges from 7 volt to 35 volt. Current rating is 1 ampere and output voltage range is 4.8 volt to 5.2 volt. Followed by that, let us dive into the pin details of 7805 IC, because studying about any IC, the pin details matter the most. Because if we don't know how to use the pin properly, we won't be able to use the IC as a whole. Okay, so now, having seen the chart, we can conclude that on taking a glance on the above chart, one can easily figure out something very interesting. There is a major difference between the input voltage and the output voltage. The input voltage is in a higher range, while on the contrary, the output voltage is in a lower range. Now, why is it so? Okay, now we know the power in a circuit is directly proportional to the voltage around its two terminals, right? Then the question arises, where does the power loss takes place? Or in a more fundamental way, where does the energy loss takes place? Where does it go? So let us see why is it so. The difference is actually released in the form of heat. Hence we need heat sinks to efficiently spread the heat loss. So the heat loss makes the difference. This is why this happens. Okay, now the time to practically do something. So guys, ready? Okay, let us see how IC7804 really works. So basically we will design and craft a simple cell phone power bank just to see how it works. Okay, the power bank will be working with basic Android phones with almost all feature phones. However, it is advised not to use it as a primary charging source. We'll be witnessing how we will regulate a 9 volt input voltage to 5 volt output voltage for our concerned usability. We will need these things: IC7805, 9 volt battery, a micro USB port, and connecting wires. Next, connect the components in this fashion: the the battery, the L7805, and the USB port. In this fashion. Okay, so here's a disclaimer: no liability for any damage to your property in whatsoever forms. This is just a formality, guys. I bet you if you use it with any feature phones, nothing will happen. And I forgot about something. the 370 ohm resistance. This is something important. This is almost at the end of our video, hence is the end of a knowledge quest for the IC7805, the fundamentals of IC7805. Of course, we'll be talking about advanced concepts later. However, let's close the chapter here. We have seen the architecture and also a short tryout. Hope you like it, and happy coding.